Look at what happens when we feed a standard Shakespeare play into the current pipeline. It immediately mutates into a neon-drenched cybernetic dystopia. The core generation system automatically forced specialized sci-fi aesthetics onto completely neutral input text. The root cause of this failure sits deep within the logic of the current comfy UI old-time radio execution pipeline. Software engineering teams call this domain leakage. It happens when specific stylistic assumptions get permanently fused into a system's foundational code. When back-end scripts force genre-specific vocabulary onto raw sources, the actual narrative outputs are inherently compromised before rendering even begins. This issue creates a hard engineering block. We simply cannot integrate public domain books or daily RSS news feeds if the system acts under the assumption that everything is a sci-fi broadcast. To see exactly where this happens, we can look closely at the remnant artifact document. Text strings like film grain and radio broadcast are hard-coded directly inside nodes.py. Hard-coding aesthetic choices at the execution layer structurally prevents the pipeline from scaling to handle new media types. Our immediate objective is to generalize the system so it can simultaneously process disparate sources, like media archives, public domain plays, and daily news, without bias. This diagram illustrates our architectural dilemma. We can either build duplicate, isolated Python stacks for every single media type, or we can build one unified engine that adapts dynamically. Building a unified, content-agnostic execution engine is the only sustainable method to avoid rewriting the underlying architecture from scratch for every new source. To permanently decouple the prompt content from the back-end execution logic, we are implementing a three-stage engineering strategy. The first target is the removal of all monolithic string prompts from the existing Python codebase. We replace them with story pack fixtures. These are isolated, swappable instruction payloads stored completely outside the execution code. By shifting away from embedded strings to strictly validated JSON formatting, we guarantee structural uniformity across very different media types. This getDiff interface compares the legacy science_news_default.json format on the left with the new mediaarchive.json templates on the right. Notice the specific removal of all futuristic vocabulary markers from the new structure. We also execute a targeted deletion of any terminology referencing analog radio hardware. In their place, the new payload inserts precise documentary restoration constraints. The entire structure shifts, binding these source-specific behaviors tightly into arrays rather than long, unpredictable text strings. The system now dynamically fetches these precise files based solely on the incoming text source metadata. Moving these instructions into discrete files completely blinds the Python backend to what it is actually rendering. It simply reads the JSON. Isolating the prompt behavior into these distinct JSON fixtures surgically removes all historical sci-fi biases from the generation chain. Once the textual constraints are extracted, we have to apply the same process to the aesthetic rendering parameters. The old system left heavy rendering remnants behind, defaulting heavily to cinematic lighting biases and inherent radio equipment overlays. This split-screen logic array compares the distinct forbidden terms and motion prompt language of the new archival documentary file against the old sci-fi radio rules. Externalizing visual tail modifications and ledger directives into these separate style files is mandatory to enable code-free aesthetic swapping. The final, most critical layer of the decoupling process is stripping all generative responsibilities away from the Python execution scripts. The legacy pipeline had a severe vulnerability. The Python scripts actively generated and concatenated raw prompt text on the fly. We replaced that with a principle called fail-loud validation, which is now the exclusive responsibility of the Python backend. To make this work, the catalogs.py routing layer evaluates incoming metadata before any generation occurs. If it detects a public domain text, the catalog inherently defaults the pipeline to the archival documentary format. Next, contracts.py acts as a strict gatekeeper, designed to block malformed data payloads. This logic tree shows what happens when contracts.py intercepts a malformed input payload. We can track the payload as it fails the rigorous structural enforcement loops. The system immediately rejects the data, triggering an assert failure before any execution logic begins. Implementing strict data type validation replaces any need for the code to understand the context of the prompts. The functional role of the Python layer shifts completely. It acts purely as a structural enforcer rather than an author. Removing the prompt generation logic from Python entirely creates a stable execution environment that is resilient to unpredictable inputs. The result of this strict separation is a pipeline capable of fluidly transitioning into highly specialized aesthetic formats. We call this finalized architecture the four-pass polymorphic engine, capable of processing extreme stylistic variations without altering a single line of underlying code. Here is the complete data flow. A raw public domain text enters the pipeline, triggering catalogs.py to fetch the archival documentary payload. It clears the validation in contracts.py and finally executes the four-pass sequence. A single, agnostic architectural pipeline processes any media type through the targeted swapping of JSON data fixtures. We are currently in the final staging phase of the overall system migration. All required JSON fixtures for both the story packs and visual styles are successfully formulated and isolated in the upstream lab. The final execution steps are explicitly documented within the transplantmanifest.md instruction set. This structural dependency graph demonstrates the module swap of the new upstream components directly into the main Comfy UI workflow. We will follow a precise sequence for safely severing and terminating the legacy hard-coded generation nodes. From that point forward, the system transitions to an absolute reliance on data-driven routing for all future media processing. Successfully completing this structural module swap permanently retires the monolithic sci-fi architecture, officially launching a truly generalized production pipeline.